With this quick demonstration, I would like to show how we can take a temperature field from one model with axisymmetric 2D mesh and map it onto our 3D model in Annex 10. Reasons why we may do so is a 2D thermal model solves faster, and then this can be mapped as a load onto a 3D structural model for more detailed analysis. Here we are in the 2D model, and we will load the thermal results. Then we will select all the elements using the identify results command to create a field. Returning to the model, we will expand the field's container and see the new field that we created. We will then export it for use in the other model. Since we are working in native mode, this will be saved on the OS. We then switch to the 3D model and import the field we just created. Note that this model has a couple of user-defined coordinate systems that we will need later, a Cartesian one and a cylindrical one. If we then select the field, we see that it's rotated 90 degrees clockwise in the global coordinate system. So the first thing we need to do is to rotate it back. To do so, we edit the field and select the spatial map. Switch to Cartesian, which allows us to select a user-defined Cartesian coordinate system, and we select the previously defined CSys 101. Now you can see the results along the same axis as the 3D model. Now we need to create the cylindrical field and take advantage of the new expressions capability in Annex 10. We define independent variable as cylindrical coordinate r, theta, and z, and the dependent results as temperature. Then we create a new expression using the fd command that references fields, in this case the previously defined ETT. Then, and this is important, we map the local x-coordinate to the r and the local z-coordinate to the z, leaving theta as 0 throughout. Finally, we select the previously defined cylindrical CSys 102. The final step is to map the temperatures to the 3D mesh. We do so by creating a temperature load and selecting the existing field, tempsil, and selecting the objects we wish to map to. To verify the temperatures have been mapped properly, we can plot the contours. And what you can see is the same temperatures as the 2D model. I hope you found this quick tip useful, and if so, please give it a thumbs up or a kudo and leave any feedback. If you would like to know how to do this in Annex 9, please click on the link below for step-by-step instructions.